Hello, everybody. How are you all? Welcome to EduSure's 50 Days, 50 Topics course for UGC NET JRF exam. Today is Mathematics Day, and we will be giving methods of differentiation to you. Okay. So, what is methods of differentiation? That is the technique to find out the derivative of a function. Okay. So, we will be dealing with y, where y will be a function of x, and we will be giving you the formulas first, that is the formulas to calculate dy by dx, or it is also written as f dash x. Okay, so here are the functions, common functions, and here are the derivatives. Okay, so if the function is y is equal to x power n, where n is a real number, then dy by dx is equal to nx n minus 1. Second, if y is equal to sine x, where then the derivative of sine x is cos x. If y is equal to cos x, then the derivative is minus sine x. Then if it is tan x, the derivative is sec square x. If it is cot x, the derivative is minus cosec square x. If it is sec x, derivative is sec x tan x. If it is cosec x, derivative is minus cosec x cot x. If it is cot x, the derivative is minus cosec square x. Okay. If it is e power x, the derivative is e power x. If it is a power x, the derivative is a power x log a. If it is log x, if the function is log x, the derivative is 1 upon x, and so on. So these are some standard formulas which you must know to calculate the derivative of function y with respect to x, where y is explained in terms of x. Okay. So now we will be discussing rules of differentiation first. So what are the rules of differentiation? So rules of differentiation are, if fx and gx are two functions, then sum rule. What is the sum rule? D by dx of fx plus gx is equal to d by dx of fx plus d by dx of gx. That means the derivative of sum of functions is equal to the sum of the derivatives of functions. Secondly, we will have difference rule. Now, what is difference rule? The derivative of difference of two functions. So the derivative of fx minus gx, that will be equal to the derivative of fx minus the derivative of gx. Okay. So this is sum rule, this is difference rule. Number 3, product rule. So what is product rule? So product rule, that means we have two functions, d by dx of two functions, fx multiplied with gx. Okay, this is going to be fx d by dx of gx plus gx d by dx of fx. This is called product rule of derivatives. Number 4, quotient rule. What is quotient rule of derivative? D by dx of quotient of two functions. So what are those two functions? Fx and gx. So d by dx of fx upon gx is denominator में आपको लिखना है gx whole square. Then numerator gx d by dx of fx minus fx d by dx of gx. And why are we doing these? Because past year question papers analysis have proved that they are asking questions on differentiation of simple functions, and simple rules are applied to calculate the derivative. So therefore we must do this. So the fifth rule is constant multiple rule. So what is constant multiple rule? It says derivative of a function fx, if it is multiplied with a constant a, is a times the derivative of the function. This is called constant multiple rule. Rule number 6, derivative of a constant is always equal to 0. So we have some standard formula on differentiation and we have the rules of differentiation, and this makes us ready to calculate the derivatives of very, very simple functions. Now, for example, we want to calculate the derivative of sin x plus x square. So this is sum of two functions. One function is sin x, other function is x square. So derivative of y will be equal to derivative of sin x plus derivative of x square. So derivative of sin x will be cos x, derivative of x square will be 2x, and we are done. Question number 2. Suppose we have to find out the derivative of x cube minus log x. Again, we will apply the difference rule. So dy by dx will be derivative of x cube minus derivative of log x. Okay, which will be 3x square minus 1 upon x. Now, question number 3, let us see constant multiple rule, how it is applied. So let y is equal to 3 times x7. So derivative will be, the constant will be written as it is, and we will be calculating the derivative of x7, which is 7x6. Okay. So these are simple rules. Now let's come to product rule. So if the question is y is equal to e power x upon sin x. So this is quotient of exponential function and sin x function. So what will be the derivative according to the quotient rule? We have to take the square of the denominator, then write the denominator as it is, differentiate the numerator, minus, write the numerator as it is, differentiate the denominator. And therefore, it will be sin x into e power x minus e power x into cos x, because the derivative of sin x is cos x, divided by sine square x. So these are simple functions, and these are the applications of all the rules that we have stated so far. Now, what happens if you have y equals to sine x cube in place of sine x? So we all knew that the derivative of sine x was cos x. But is the derivative of sine x cube cos x cube? The answer is no, because I have x cube in place of x. So now we introduce something which is known as chain rule. Chain rule. Okay. So what is the chain rule of derivative? Start with the outermost function. Start with the outermost function to differentiate, and end with the innermost function. Innermost function. What does it mean? Let us see. For example, y was sine x cube. So here the outermost function is sine. So what you will do? Dy by dx. What is the derivative of sine? Cos. And please do not touch whatever is inside. Write it as it is. Now multiply it with the derivative of whatever is remaining. The remaining is x cube. So that is going to be cos x cube into 3x square. Okay. Now this was a very simple chain. Now suppose the question was like this: y is equal to sine cube x. So basically this is nothing but sine x whole cube. Please remember that sine cube x is not equal to sine x cube. The left hand side is sin x multiplied by sin x multiplied by sin x, while the right hand side is sine of x multiplied by x multiplied by x. Okay. So therefore, this is what is happening as far as the expression sine cube x and sine of x cube is concerned. Now here, when we calculate the derivative, we cannot calculate the derivative of sine x directly, because there is a power involved. So we all know that the derivative of x power n is nxn minus 1. So here let us differentiate this power. So we will have 3, then sin x whole power 3 minus 1, and then follow the chain. What is inside? Sin x. So this will be 3 sin x whole square into cos x. Okay. Now suppose you have to calculate the derivative of sine cube x square. So what will you do? You have to look at this power first. So 3 sine square x square. Now, after the power is done, differentiate the function cos x square. Now, after sine is also done, differentiate x square, 2x. So this is how we follow the chain. Let's do one more example. Suppose you have to do the derivative of log 7 cos tan x5 plus 8. Okay. Now, what is the outermost function? The power. So 7 log 6. Write whatever is inside as it is. Then multiply with the derivative of log. What is the derivative of log? 1 upon x. What is the x here? Whatever is inside log. So cos tan x5 plus 8. Okay. After that, what is inside cos? So now what is happening? You have differentiated log. So now you will be differentiating cos. So what is the derivative of cos? Minus sine tan x5 plus 8. Now after the derivative of cos, we will have to differentiate this tan. So that is going to be sec square x5 plus 8. And now what is remaining inside 10 x5 plus 8? What is the derivative of x5? 5x4. And what is the derivative of 8? 0. So this is how chain has to follow. We have to start with the power, then go to log, then go to cos, then go to tan. And then what was my innermost function? That is x5 plus 8. This is called chain rule of derivatives, and it is the father of all the rules of differentiation. So you need the basic formulas of differentiation, you need the basic rules of differentiation, and you need the chain rule to calculate the derivative of a function. Now, the next topic is logarithmic differentiation. So what is logarithmic differentiation? Let us see. Logarithmic differentiation. Logarithmic differentiation is useful when we have powers in terms of x. Okay, what do we mean by that? Suppose we have y equals to x power x. Okay, and we apply the power rule x into x power x minus 1. This is wrong because the power rule says if y is equal to x power n, where n is a real number. So n cannot be a variable, it has to be a real number. Then dy by dx is equal to nx n minus 1. But here y is a function of x. So x is a variable and the power is also x. So we cannot apply the power rule. Then what will we come to our rescue? That is logarithms. So let's learn some logarithms. So first of all, log is always defined with respect to the base e generally. If it is given without a base, the base will be e. Then whatever is inside log, it has to be positive. Log is not defined for 0 or negative numbers. Then there are certain rules. Log x plus log y is log xy. Second, log x minus log y is log x upon y. Third, log x power m is m log x. These are the three rules of differentiation, and this is the definition of log to help us use logarithmic differentiation for our help. Okay, so now take log on both sides. So when we take log on both the sides, we will have log y is equal to log x power x. Okay, so log y will become, now this is the power, so use the third rule. This will become x log x, x into log x. So now differentiate both sides with respect to x. So you will have d by dx of log y is equal to d by dx of x into log x. Now on the left hand side, we will be using chain rule. So what is the derivative of log y? 1 upon y. What is the derivative of y? Dy by dx, because this is not x, this is y. So first we apply the derivative on log and then we apply the derivative on y. And this will be u into v. So x d by dx of log x plus log x d by dx of x. So this implies dy by dx is equal to y x. What is the derivative of log x? 1 upon x plus log x. What is the derivative of x? So this is how we calculate the derivative when we have powers in terms of x. Let us take one more example. Suppose y is equal to x power sine x. Then we take log on both the sides. So log y will be log x power sine x. So again the power will come out. It will be sine x into log x. Now differentiate both sides with respect to x. So derivative of log y will be 1 upon y dy by dx. Then we will apply product rule on the right hand side. So sine x into derivative of log x plus log x into derivative of sine x. So finally dy by dx will simplify to be y sine x upon x plus log x into cos x. So this is the concept of derivative of a function in terms of logarithms. We are doing logarithmic differentiation. Now the next type of differentiation is parametric differentiation. What is parametric differentiation? So in parametric differentiation, the variables y and x will be given in terms of a third variable. For example, if x is equal to t square, y is equal to t cube. So how will you calculate dy by dx? That will be dy by dx, dy by dt, because y is explained in terms of t, divided by dx by dt. Now what is dy by dt? By power rule 3t square. And what is dx by dt? By power rule 2t. So this is 3 by 2t. Similarly, if x is equal to sine t, y is equal to cos t, then what is dy by dx? So dy by dx will be equal to dy by dt divided by dx by dt. What is dy by dt? Minus sine t. What is dx by dt? Cos t. So this will come out to be minus tan t. Similarly, if x is equal to e की power t, y is equal to log t, then what will be dy by dt? It will be dy by dx. It will be dy by dt divided by dx by dt. What will be dy by dt? 1 upon 2. What will be dx by dt? E power t. So what will it be? 1 upon t e power t. This is called parametric differentiation. So parametric differentiation is useful to calculate dy by dx when both y and x are explained in terms of a third variable. Okay, and the formula is given. It is not very difficult. It is simple. Now, the next type of differentiation. The next type of differentiation is where you have to find out. For example, somebody says calculate the derivative of sine x with respect to tan x. So basically, right till now, what we were doing, we were calculating the derivative of y with respect to x, where y was explained in terms of x. Now, what are they asking you? They are asking you to calculate the derivative of sine x with respect to tan x. So what you do, you consider u equals to sine x and you consider v equals to tan x. So basically what you are supposed to find out, you are supposed to find out du by dv. So it is nothing but parametric differentiation written in another way. So what is du by dv? It will be du by dx divided by dv by dx. So what is du by dx? Cos x. And what is dv by dx? Sec square x. Similarly, if you have to calculate the derivative of e power 3x with respect to log 7x, So again, u equals to e power 3x, v equals to log 7x. So you have to find out du by dv, which is du by dx divided by dv by dx. So what is du by dx? What is the derivative of e power 3x? E power 3x into derivative of 3x, that is chain rule, which is 3. What is derivative of log 7x? What is the derivative of log? 1 upon whatever is inside, and then we have to differentiate whatever was inside as per the chain rule. So it is going to be this. So it will be x 3x e power 3x. That is the derivative. So this type of differentiation where we have to differentiate one function in terms of x, this is nothing but parametric differentiation written in another way. All right. Now, we also have higher order derivatives. So what are higher order derivatives? So higher order derivative means I want to find out f double dash x, which is nothing but d by dx of dy by dx. Okay. Similarly, f triple dash x. So this is second derivative is also written down as d2y by dx2. Third derivative d3y by dx3. That means we have to differentiate 3 times. So let's take an example. Suppose y is equal to sine x. So what is your dy by dx? Cos x. If I differentiate this again, I will get d2y by dx2. And what is the derivative of cos x? Minus sine. If I differentiate again, what will I get? d3y by dx3. And what is the derivative of minus sine x? Minus derivative of sine x, which is cos x. And the story will go on. Now, there is a trick to calculate the second order derivative of parametric functions. Let's see how. Suppose y is equal to t square and x is equal to t cube. Then dy by dx is equal to, we all know that it is dy by dt divided by dx by dt by parametric differentiation. Dy by dt is 2t, dx by dt is 3t square, which is 2 upon 3t. So what is your dy by dx coming out to be? Dy by dx is coming out to be 2 upon 3t power minus 1. Now, suppose I want to calculate d2y by dx2. This is nothing but d by dx of the first derivative. The constant will come out by constant multiple rule. Okay. Now, d by dx of t power minus 1. Apply power rule. Minus 1, t power minus 1, minus 1. Now, you will have to calculate the derivative of t with respect to x because we are following chain rule. So, this is minus 2 by 3, t power minus 2, dt by dx. What is dt by dx? 1 upon dx by dt. So, minus 2 by 3, t square will come in the denominator. 1 upon dx by dt. What was your dx by dt? What is your dx by dt? That is 3t square. So that is minus 2 by 3 t4. Okay. Now, please remember one thing. d2y by dx2 is not equals to d2y by dt2 divided by d2x by dt2. Please do not make this error. When we are doing parametric differentiation, to calculate the first derivative, this formula is applicable. To calculate the second derivative, this formula is not true. We have to do it by chain rule like we have done in this particular question. So this is the basic structure of method of differentiation. So how do you attempt differentiation or how do you prepare for differentiation for UGC NET? First, you learn standard formulae. Okay. Second, you should know rules of differentiation. So what were the rules? Sum, difference, product, quotient, constant, multiple rule. Third, you should know chain rule. This is the father of all the rules. Without chain rule, you will not be able to survive. Fourth, types of differentiation: direct, Logarithmic. When do we do logarithmic differentiation? When powers are in x. In x. Parametric. Okay. And higher order derivatives. So for UGC NET JRF, if you know this much, you will be able to sail through the questions on differentiation. This is all for today. Thank you very much for joining EduSure. Keep on coming to our channel. Keep on visiting our channel for more such topics which are very much relevant for your preparation for UGC NET and JRF. All the best. See you next week.